Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be continuing our exploration of slope-intercept form of a line. Now, as a way of review, we can write linear functions that represent real-world situations if we know the initial value, or the y-intercept, and the rate of change of the function. To do this, we can use the equation y equals mx plus b, where m represents the rate of change or slope, and b represents the y-intercept or the initial value. So in example 1, it says a water tank currently holds 275 gallons of water. The amount of water in the tank will decrease, and this is very important, at a constant rate of 15 gallons per week. So in part A, they want us to write an equation that represents this situation. So we'll say y equals, the rate of change was 15, a decrease of 15 gallons per week, and the initial value was 275 gallons. Now, in part B, they want us to make a table of values for this equation. So I'm going to come over here to my graphing calculator, and I'm going to put in our original equation here, y equals negative 15x plus 275. And I'm going to make a table. Now, if you've never done this before in Desmos, once you put your equation in, you can tap this little gear, and you have some choices here. I'm going to choose the table. And these values that come in pre-filled, -2, -1, those are not really the values we want. So I'm going to replace them with the values we want, which is 0 weeks, 5 weeks, 10 weeks, and 15 weeks. Okay, we don't really need anything else than that. So at 0 weeks, we had 275 gallons. At 5 weeks, there were 200 gallons left. 10 weeks, there were 125 gallons left. And at 15 weeks, there were 50 gallons left. Now, we can create a graph of this situation. Notice the graph. On the x-axis, we have time in weeks. And on the y-axis, we have the water remaining. So our first point is at 0 to 75. Now, I do want you to notice that on your y-axis, they are going up by 25. So 25, 50, 75, 100, and so on. So 275 would be right here. And that would be our initial value, 0 to 75. And then 5, 200 would be right here. 10, 125 right here. And 15, 50 would be right here. So here is the graph of this situation. Okay. Example 2. Jackson bought a new computer. He made an initial payment of $50 to the store, and he will pay $30 each month until the computer is paid off. Write an equation to represent this situation. So his initial payment was $50 plus $30 per month. So our rate of change is 30. So 30 per month. And then his initial payment was $50. So y equals 30x plus 50. So I'm going to come over here, and I'm going to X these out, and I'm going to put in our new equation, y equals 30x plus 50. Now, I'm going to hit the gear button because I want to make another table for this. And I'll change these numbers to 0, 5, 10, and 15. And I'll just delete those values. Okay, so in 0 months, Jackson had paid $50. After 5 months, he had paid $200. After 10 months, $350, and after 15 months, $500. So if I plot this, notice our graph. We have time in months on the x-axis, and on the y-axis we have the total amount paid, and the y-axis is scaled by 50s. So at 0 months, Jackson had paid $50. At 5 months, he had paid $200. 10 months, $350. 15 months, $500. So there's our linear relationship. All right, example 3. Marissa needs to write an equation in slope-intercept form to represent the linear relationship between x and y shown in the table. To do this, she must find the slope and the y-intercept. Help her find the missing information. So let's start off by finding the slope. Remember, we can find the slope by using the formula y2 minus y1 over x2 minus x1. So to do this, we need to pick 2 friendly points. Actually, in this table, all the points are pretty friendly, so I'll just use the first 2. 0, 6, and 1, 2. So I'll make a fraction here. I want to take the second y, which is 2, minus the first y, which is 6. And then on the bottom, take the second x, which is 1, minus the first x, which is 0. So this would be negative 4 over 1, which reduces to negative 4. So we have a slope of negative 4. Now, the y-intercept is the value of y when x equals 0. So our y-intercept in this problem is 0, 6. Now I'm going to put those together to write an equation. Y is equal to negative 4x plus 6. All right, example 4. Write an equation in slope-intercept form to represent each linear relationship. All right, so in problem A, we want to first of all get the slope of the line. So I'm going to pick 2 friendly points. Maybe I'll use 0, 6, and I'll use 10, 18.5. 10, 18.5. So I'll take my second y, 18.5, minus my first y, 6, and then my second x, 10, minus my first x, 0. Now come over here to my calculator, press the division button. 18.5 minus 6 goes on top. 10 minus 0 goes on the bottom, and that gives me a slope of 1.25. Now, the y-intercept occurs wherever x equals 0, so our y-intercept in this problem is 0, 6. And then we're going to put those together to write an equation. Y equals 1.25x plus 6. All right, next problem, problem B. We want the slope. Now, all of our points are pretty friendly here, so I'll just use the first 2 points, 2, 50 and 4, 90. And I'm going to take the second y minus the first y, so 90 minus 50. And then the second x, which is 4, minus the first x, which is 2. I'll come over to my calculator, press the division bar, 90 minus 50, and on the bottom, 4 minus 2, and that reduces to a slope of positive 20. Now, on the y-intercept, it's a little more difficult in this problem to find the y-intercept because our table of values, if you look at the x's, there is no 0. But we can work backwards and find it. So notice we go 8, 6, 4, 2. If we went backwards one more time, we would land on 0. So 0, 2, 4, 6, 8. All right. On the y's, let's see. We're going 170 to 130. That's down 40. Then we go down 40 again to get to 90. We go down 40 again to get to 50. If we went down 40 again, 50 minus 40 would give us 10. So we have a y-intercept of 0, 10. Now we can put that together to write our equation. Y equals 20x plus 10. All right, our next table, we want to get the slope. So it looks like we're not going to be able to avoid negatives. That's okay. I'll just use my first 2 points, 3, -6, and 6, -12. So I'll take my second y, which is -12, and subtract my first y, which is -6. And then my second x, which is 6, minus my first x, which is 3. All right, I'll come over here to Desmos. I'm going to press the division button. So on the top, -12 minus -6. On the bottom, 6 minus 3. And that reduces to a slope of -2. All right, now my y-intercept. Let's look and see if we can find the pattern in the table. If I go from 12 to 9, that's down 3. If I go down 3 again, that would put me at 6. If I go down 3 again, that would put me at 3. If I go down 3 again, that would put me at 0. So let's see what happens on the y values. -24. So if we go up 6, that would land us at -18. Go up 6 again, that lands us at -12. Go up 6 again, that lands us at -6. Go up 6 again, that lands us at 0. So that means our y-intercept in this problem is 0, 0. So our equation would simply be y equals -2x. All right, example 5. The ticket sales for a concert start at 4:00 p.m. The table shows the linear relationship between the number of tickets remaining and the number of hours since 4 p.m. So to find the slope, I need to just use my first 2 points. So I'm going to use 1, 12,000 and 2, 9,000. Now, if I use my slope formula, this would be 9,000 minus 12,000. And then on my x values, 2 minus 1. Now, on the calculator, I'm going to press the division bar. 9,000 minus 12,000. On the bottom, 2 minus 1. So that gives me a slope of -3,000. So the number, what does it mean? Tickets are decreasing because it's negative at a rate of 3,000 per hour. Now, they want to know how many tickets were originally for sale. So when the time was 0. So if we go backwards, 4 to 3, back 1 would be 2, minus 1 would be 1, minus 1 would be 0. So now we start at 3,000. If we go up 3,000, that'd be 6. Up 3,000 again, that'd be 9. Up 3,000 again, 12,000. Up 3,000 again, this would be 15,000. So this was the original number of tickets that were for sale. So write an equation to describe the relationship between the number of remaining tickets with respect to the time. So y would equal -3,000x plus 15,000. All right, example 4. A gym charges a membership fee plus an additional fee per yoga class. The table shows the relationship between the number of yoga classes taken and the total cost, including the membership fee. So the first thing they want to know is what is the slope and what does it represent? Now I'm going to pick two friendly points. I'm going to use 8, 75 and 20, 120. So if I use my slope formula, we would do 120 minus 75 over 20 minus 8. Now let's put that into Desmos. Hit my division button. 120 minus 75 over 20 minus 8. Whoops, not 7. 8. That would be 3.75. So the slope would represent the cost per class. Now, what is the cost of the membership fee? In other words, if you've taken 0 classes, how much would the cost be? So let's look here. Let's see. We're going from 10 to 8. That's down 2. 8 to 6. That's down 2. Go down 2. That would give me 4. Go down 2 again. 2. Go down 2 again. That would be 0. So we need to find the total cost when x is 0. So let's see what this is going down by every time. So I'm going to take 70, excuse me, 82.5 minus 75, went down 7.5. Then 75 minus 67.5. So it looks like it's going down 7.5 every time. So 67.5 minus 7.5. So this would be 60. Then go 60 minus 7.5. That would give us 52.5. Do that one more time. 52.5 minus 7.5. And that would land us at $45. So the cost of the membership fee would be $45. Now, to write an equation for this, y equals, we want the slope, 3.75x, plus the initial value, plus $45. And that concludes today's lesson on slope-intercept form part 2.